Alright, so we have a question before us which says that a gardener is building a sheep pen by erecting 3 sides of a fence to form a rectangle. We are also told that he has 40 meters of fence to use, and finally we need to find the maximum area and corresponding dimensions of the pen. Okay, so that is our question. What's the first thing we're going to do? The first thing that I would do is draw a picture of my sheep pen, which has 3 sides and is a rectangle. Now, obviously, if it has 3 sides, I'm going to have to be building it off a pre-existing wall. Otherwise, the sheep are just going to be, just running away. They're just going to be running away. So that can't be what's happening. So I'm building off a pre-existing wall. Not that that really matters. And as you can see here, I have 3 sides. I have my width, I have my length, and I have my width again. Perfect. So that's my first step. Draw a picture. My next step will be reading this sentence in which I'm told that he has 40 meters of fence to use. Alright, so if I have 40 meters of fence to use, then that means I can figure out what my perimeter is going to be. My perimeter will be 40 equals W plus my W plus my length. W plus W plus my length. And of course, a better way to write this would be 2W plus L. Perfect. I have my perimeter. The question really centered around my area, finding what my maximum area is going to be. So now I'm going to have to write a rule for my area. And that is obviously going to be my area equals my length times my width. We all know that to be the rule for my area. Okay, so now what am I going to do? I have my perimeter, I have my area, but now, knowing that my question centers around finding my maximum area, I'm going to have to manipulate this. And what I'm precisely going to have to do is get my area in terms of one variable. So I don't want it in terms of L and W, I just want one. I want it to either be in terms of L or to be in terms of W. And to achieve that end, I'm going to have to manipulate my perimeter here. So as you can see here, I could rearrange this to make, let's say, L my subject. So I could rewrite it so it is L equals 40 minus 2W. So all I've done is minus 2W from both sides. And having now written this, and let me now actually put this into a different color because it's very important, I can now put this into my area rule in order to get my area purely in terms of W. So let me now write that. I'm now going to write area equals, and instead of writing L, I know that L equals this. So what I can do, let me actually, to really drive home the point, I will copy it and paste it in there and do this, W. So in my L spot, I put L equals this. I put this right there. I now, in my next step, I'm going to expand. So I'm going to get 40W minus 2W squared. So now, as you can see, because I have this squared, I have a quadratic. So let me write this in the conventional way of a quadratic with my squared value first, 2W squared plus 40W. Perfect. So now we have a really nice rule to work off to find out what my maximum area is going to be. So to find my maximum area, what I'll be finding is where my A value, right here, where my A value will be the greatest. Now, this is kind of hard to picture when we're doing it purely abstractly. So let's again draw a picture. So this time, let's draw a graph of this quadratic. So let me come over here. And I'm going to draw this right here. So here are my axes. So as you can imagine, this is going to be A, and this is going to be W. So this is kind of my vertical axis, this is my horizontal axis, and that's because I have A equals, and then it's in terms of W. All right, so now I need to draw it, so I'm going to have to figure out what my W-intercepts are going to be. So what is my W-intercepts going to be? And obviously, my W-intercepts are going to occur when A equals 0. So I'm going to write A equals minus 2W squared plus 40W. I then am going to take out a common, and I'm going to set A equal to 0. That's the whole reason why we're doing this. And now, to solve this, I'm going to take out a common factor, which can be 2W. So I'm going to be left with 2W on the outside. Then here, I'll be left with minus W. plus 20. Perfect, because 2w times 20 is 40w. And then from here, I'm going to set both of these. So I will set both of these, this one and this one, equal to 0. So I'm going to have 2w equals 0, which simply means w equals 0. So that is going to be one of my intercepts. So w equals 0, so it'll be right here, 0. And my other one will be when negative w plus 20 equals 0. Negative w plus 20 equals 0. I will do some rearranging, and that will obviously be w equals 20. So that will be my other intercept. So I come over here, and let's say this is 20. All right. Having drawn this now, I can draw, having found my intercepts, I can now draw my parabola. Let's take a note of the fact that I have a negative in front of my squared value, which means it's going to be an upside down parabola. So it will look like this. And I have not drawn, let's move this over here. Perfect. So there's my parabola. So here are my points. So now I need to figure out where I have the biggest A value, my maximum A value. So where am I going to find, let me come get another color. Where am I going to find my biggest A value? Well, it's obviously going to be here. That's where my biggest A value is going to be, so here. So how am I going to find this value? Well, obviously, because we're dealing with a quadratic, it's going to be smack dab in the middle of these two. So it's going to be 10. So when my width is 10, I'm going to get out my biggest area. When my width is 10, I'm going to get out my biggest area. So now all I have to do is sub 10 into this formula. So let us now do that. So let me kind of scroll here for a second. And I'm going to say, all right, so now I have A equals negative 2w, whoops, sorry, in place of w, we are putting 10. We are putting 10. I'm going to square that, plus 40, and then in the w spot, we're putting 10. All right, let's keep going. So I'm going to get area equals minus 2. 10 squared is 100. Plus 40 times 10 is 400. I'm going to get area equals minus 2 times 100 is minus 200. Plus 400. Minus 200 plus 400 is 200. So we just found out what my maximum area is going to be. My maximum area is going to be 200. And actually, the proper way to write this would be, because it is, we're dealing with meters obviously, it is going to be, and I would write this out, my max area is 200 meters squared. And I could put it therefore. Now, I imagine if this was a question in a test, lots of us would write this and then stop and then go on to our next question because you think you've gotten to the final answer. We're close to the final answer, but let's go up and remind ourselves that we need to find the maximum area and my corresponding dimensions. So in other words, I need to figure out what my length will be. So that isn't hard. All I have to do is find out what my length is. I need to sub in 10 here. So I'm going to go, my length is going to be 40 minus 2, 10, because I know that's my width when my area is the greatest. And then I'll go L equals 40 minus 20. My length is going to equal 20. So therefore, my dimensions will be my width, which is 10, times my length, which is 20, for max area. And that right there will be the second part of my answer. And see, even I make these little things, little mistakes. What you should really do, is write meters. Always put the units in. You never want to get caught up on that. 10 meters by 20 meters for a maximum area of 200 meters squared. Hopefully this was helpful. This is a question that I talked through in class. So if you did get stuck in class, I've just made this little video to help you think more clearly about this and really showing you the power of quadratics to figure out real world problems.